Alright, so when we talk about circuit elements in series, this is what we generally know. But there are a lot of arrangements in which we can still happen to get the element in series, but it will not be of this form. Okay. But this is the thing. Whenever you want to find out whether two elements in a circuit are in series or not, that's what you do. You check whether the same current flows through them. So looking at this one, this is the only voltage source. So if a current comes from here and it passes through this one, it's the same current that will pass through this one, right? So if here is I1, the current here to be I1, this is the same current, right? Yeah. But what if you don't know the actual current there? Like you don't know how the system is actually configured. This is what you do. You check if there's no junction or there's no node between the two prior circuit elements. So looking at this one, we are on this figure 1, right? The voltage source here, positive, negative. Moves from here, the same current pass here and the same current pass here. When you look at this particular place, you can actually move across these two resistors without passing through any other branch, right? So you can move to them straightly. There's no way if a current is coming from this side. If a current is flowing from the voltage source, which is here, there is no way that it will pass another way aside from passing through this, because all the current that pass through this R1 will pass through this R2, right? Then they are in series. Okay. When you look at this particular figure 2, you see that when the current is flowing from this side, let's say it's coming from this side, when it passes through this one, it gets to this particular place, there's a chance it actually has to split, right? The current will have to split between here and here. So meaning not all the current that passes through this R1 will pass through this R2, right? So some of the current passes somewhere else. So we can see clearly that R1 and R2 are not in series, right? And then again, it's also clear that it's also clear that R1 and then R3 are not in series, right? So R1 and R3 are not in series, right? So look at this. When the current from R1 trying to get to R3, some of the current will pass here, so right, they are not in series. Okay, there's another one. Looking at this one, which of the resistors do you consider to be in series? Right, this is the voltage source, right? So let's say a current is going from here, right, and it gets here, right? Definitely at this point the current is split into two, right? The current that is moving along this path, right? Let's see if this is I1, let's say IA. The same IA will pass through this one and then this one, right? So let's use color codes to see what's happening. The same current to pass through this and then this. So we can see that R1 and then R2 are in series, right? R2 are in series. And then when this particular current here, let's say if this is IB, the same IB will pass through R5 and then R6. So we can see that R5 and R6 are in series, right? Is there any other? There is no other. Looking at this current here will pass through this and this, pass here, and then when it comes here it will split. Looking at, okay, the current will coming back to this one, so right, this will pass here and then the rest of these ones will come and pass here, so they meet here. Here there are two currents, so we can't say this one is in series with any of them, right? But definitely it is clear that R1 and R2 are in series, right? Because the same current pass through them, and then R5 and R6 are in series, right? Yeah. Oh yeah. So you see R3 and then R4, right? Doesn't make sense that they are in series. Let's check it. So we're seeing that if they are in series, the same current should flow through them, right? So let's see. Okay, we are seeing that this is the voltage source, right? Positive terminal, negative terminal. So all the current that is in the circuit start from here, right? So see, if this is the current here that gets to this point, that splits into this IA and then IB, right? And then this IA move along this direction. IA moves and then come here, right? So we have IA entering this side, right? And then IB moves along this path and come here. IB to getting here. So right, so everything that began, right, that split, what began that split into these two has now come back to enter this I4, showing that this was showing that R4 and then R3 are in series. Are we okay? Yeah. So R1, R2 is series, the red guys. R3 and R4 are in series. They are the green guys. So they are the blue guys. And then we have R5 and R6 are also in series, the green, right? So yeah. Then again, and when it comes to series circuit, whenever you have a circuit that the element that are in that particular circuit are in series, like of this form, if you want to find the total resistance, provided all of them are in series, you can just add them up, right? So let's see, I'm trying to find the total resistance in the circuit, in this sort of circuit, right? Now we know the groupings and we know how they are. So let's see. At times the total resistance can be termed effective resistance, right? Yeah, total resistance, effective resistance, or sum of the resistances, right? So these are all the same things, nothing different, just the same thing, right? So when it comes to circuit where we know the resistors in series, there's a way to find them, right? Looking at this one here, you have to use a combination of resistors in series and then resistors in parallel, right? But let me give another example, then we'll come back to this one. So let's see. Let's say we have a circuit of this sort, and there's one resistor here, and a resistor here, and a resistor here, and there's straightforward just a voltage source, right? Then again, it's not always that you see the positive and negative terminal. The long one's positive, short one negative. It's not always that you see a circuit of this sort, but let's see if it happens that you haven't the resistors to be in this arrangement, all of them to be in this arrangement, then the effective resistance or the total resistance, right? I'm just writing the symbols how they are written. The effective resistance or the total resistance is just by adding them, right? R1 plus R2 plus R3, right? But now let's use this circuit as an example. Looking at this one, if you've not done the resistors in parallel, I think you have to check that one too out. Looking at this circuit in particular, you see that we know, and now we are very clear aware that these two are in series, right? And then these two are in series, and we know that these two are in series, right? But then this is what happens when you consider these two in series, meaning that you can add them to get just one resistor. So let's say 1, 2, right? You can add these guys up and together, let's say R5, 6, right? So if you are trying to transform the circuit, it will be something of this. Simplify the circuit, that's the right term. It will be something of this sort. You have something, let's see. And we know these two to be in series, right? So let's say R3, 4, right? And then there's the voltage source. And we have another one, let's say R1, 2, right? And this one is R5, 6, right? Looking at this one, when you get here, you'll be like, if you want to do everything in series, you should be stacked, right? So looking at, when you simplify the circuit to this sort, let me just use dashes here to show that it's R1, 2, R3, 4, R5, 6. But that's what I'm trying to see. Okay. When you get to this point, you still want to simplify the circuit to get just one resistor, or the effective resistance that we're talking about. This is what you do. You see that this R1, 2 and the R5, 6 are not in series, right? Are they in series? No. Because if, let's say, the current is coming from this side, it will definitely split into this and then this, which will be different resistances, so they are not the same thing. So in order to simplify this one, what you do is that you see that this R1, 2 and the R5, 6 are actually in parallel. So if you've not checked that one, I think you should check that one too. So what happens is that you get R1, 2 and then R5, 6 in parallel. Generally write them this way, right? But before you get this R1, 2, you just have to sum them, right? Before you get R5, 6, you just have to sum them, right? Doing this will give you the effective resistance of these two. So it will be something like this, so product of a sum. So for these two, the effective resistance will just be R1, 2 times R5, 6 all over R1, 2 plus R5, 6, right? That's what happens with this one. When you get this one, you end up getting just one resistance, meaning that the circuit can be simplified further, right? So you'll be getting something like this. Let's see. So the voltage source is here, right? And then you get the next resistance. You can put it anywhere, so far as you obey the concept, right? So it's something like this, right? And then you get the next one, and that's it. There's the voltage source, and then this one here is R34, right? Because it moves directly. This one moves directly through it, right? And then the next one will be R. Let me write this because it's a bit complex. It will be the result to be R1, 2 in parallel with R5, 6, So the whole of here is this resistance here, right? Yeah. So to find the final effective resistance, this is how it to be. This one here is what do you get from doing this one here, right? So the total resistance will be this R1 2 in parallel with R5 6, right, plus R3 and 4, right, which we know to be the sum of them, so be something like this: R1 2 in parallel with R5 6, right, plus R3 plus R4, right. This is what you should be getting in the end. So this is what will give you the effective resistance of all the circuit here. Alright.